headache when they leave for work. All right, variable device. If you haven't noticed, all the devices that we learned about just now were low flow, which means they are variable, which means the FiO2 is not fixed, it changes. It's somewhere in the range that is given. So the non-rebreather is 60 to 80%, somewhere in there, depending on how fast or slow they're breathing. And that's it for the low flow devices. Not hard, right? No. Okay, now let's make it hard. That was a joke I'm sure y'all didn't think was funny, but it's okay. We are going to do a little math. So, with the nasal cannula and the simple mask. This nasal cannula, NC and SM, nasal cannula, simple mask. I know it's backwards, I'm sorry, I don't know what to tell you. I'll redo the math in lab. All right, these two devices, we can estimate how much FiO2 a patient's on based on their flow. So we have 21% oxygen in room air, and then we're going to take, 21% plus 3 to 4% per a liter. Interesting. So every liter you have a patient on the flow meter using a nasal cannula simple mask, every liter the FiO2 goes up by 3 to 4%, and we start at 21. So for easy math, I do 20 plus, and I either pick 3 or 4, but just because I don't want to pick, I'm going to do 3.5 times the liters per a minute. And that'll give you an estimated FiO2. So if you are on a 0.5, and we had somebody on a 3-liter nasal cannula, their FiO2 would be 3 times 3.5, which is 10.5 10.5% plus 20 equals 30.5%. So that person's getting about 31% FiO2. That's how you estimate that. So I have a lot of whiteboards, hold on. So if you had a simple mask at 3.5, the simple mask was on 10 liters per minute, you would have 20 plus 35 equals 55% FiO2. It's a little high because technically you can only go to 50, but close enough because it's an estimate. So that's how you estimate, and it only works on a nasal cannula and a simple mask. It only works on those. I wish I had a mirror to hold this up to so you could see it straight, but I don't. If you know a way to flip these, let me know and I'll flip them. All right. So that's how you estimate FiO2 on a variable device, simple mask, and nasal cannula. It only works on those two. All right. I was going to show you the math and get into the Venturi device, but I'm not going to show you the math for the Venturi device because it's backwards and it's pretty, I mean, that I just showed you was simple, straightforward, addition, multiplication, but the actual entrainment math is more ratios and stuff. So I am going to show you the Venturi device and talk about the parts to it, and then we'll run through them again and talk about which one you'd be using for which patient. All right, All right, so the Venturi device in the lecture PowerPoint, I was talking about the orifice size, fixed and variable orifices. So with, where's my simple mask? With the simple mask, you attach this to the flow meter, and that's the orifice. That is the orifice size. It's fixed. It's one size fits all. So if you have 3 liters going through this tubing, the pressure is lower than if you had 10 liters because you're shoving it through a smaller space. All right, so that's a fixed orifice. The Venturi device is a variable orifice, and it depends on which one of these we use. They're so colorful. I might keep these for my classroom. Orange. Yes, because if you haven't figured it out, this is where I teach Chinese kids English. Yeah, my favorite prop to use, Mr. Potato Head. All right. So, Venturi devices. All right, so the Venturi device uses orifices. Oops, I keep forgetting where my camera is on this device. So, the pink device has a bigger orifice than, let's say, the orange. Yeah. So if you look down, you can see that orange is definitely bigger than pink, right? So these are other gas law Venturi principles and Bernoulli principle, which we'll get into in class. But for this device, you have a whole bunch of parts. You have an aerosol mask, not a simple mask because your finger goes through it. A simple mask doesn't let you do fancy things with it. It's simple, very, very simple. This mask is the aerosol mask, and when aerosol's coming through it, it looks like you're steaming, or it's not simple because you can make it into other things. That's how I remember it. Aerosol mask. Corrugated tubing. You attach your corrugated tubing to the aerosol mask. And now you have the parts that deliver the oxygen are going to go inside your cup area, Venturi cup. So this sits in here like this, and then this attaches to the devices. So the Venturi mask, also known as a Venti mask, V-E-N-T-I, like Venti coffee. It stands for Venturi.